Hi, this is Mrs. Segala, and this is a homework for assignment 2.1. Okay, and this assignment was due actually on September 15th. All right, so in this unit 2.1, we covered how we classify matter and a lot of the different properties. And so what is matter? Matter is anything that has mass. And takes up space. So basically everything that's found within our universe is considered matter, with the exception of energy, okay? Because energy does not have mass and it doesn't take up any space. So we talked about three properties of solids, and you remember these from middle school. Solids, again, they have a definite shape. They have a definite volume, so the volume doesn't change. And pressure has no effect on solids. They will retain their volume or their shape, or I'm sorry, their mass. Okay, we look at liquids. Liquids do not have a definite shape. Okay, so no definite shape. They'll basically take on the shape of whatever container they're in. However, they do have a definite volume, okay? And pressure has no effect on a liquid, okay? So pressure, meaning that we can't compress liquids into smaller sizes. Okay. Now we go to gases, okay? Gases, again, they're similar to liquids in the fact that they don't have a definite shape. Now, gases are different from liquids and solids because gases can be compressed, and also gases will take up as much space as they can. So in this case, gases have no definite volume. Pressure does have an effect on gases, because we can squeeze these molecules even closer to each other. When you think of this, think about a tank of helium and how that tank of helium you can blow up to maybe 50 balloons. Those 50 balloons are going to take up a lot more space than that tank of helium, because inside that tank, those gas particles, those helium molecule or atoms, are compressed closely to each other. Next, we looked at properties, okay, and we looked at physical and chemical properties. Again, remember your definitions of a physical property is one of those that can be observed without having your matter change to something else. A chemical property can only be observed only if that matter changes to something else, or doesn't allow to keep its same identity. So when we observe color, we know that's a physical property. Density, well, we can measure density, and that object isn't going to change to something else. Flammability, if we take a piece of paper, in order to observe that that piece of paper is flammable, it will change. Okay, we catch it on fire, and again, it's going to end up being ashes. Next one, solubility. This is a new vocabulary word. Solubility is the ability of a substance to dissolve in a liquid. And so let's say, for example, you take some salt, you can dissolve salt in some water, so salt is soluble. However, is that a physical property or a chemical property? Well, if we were to do that, we would still have salt and water. Okay, so no, there's no change, so it would be a physical property. Reacts with acid to form hydrogen gas. Whenever you see this word reacts, that means that it has to change. So in this case, it would be a chemical change. Combusts, okay, again, combusts, reacts, explodes, all those would be chemical. A sour taste, let's say you have a Sour Patch candy, you take a lick, you lick it a little bit, you can taste that it's sour, it didn't change to something else, okay? So that would be a physical property. Mass, physical property because you can observe it. Reacts, again, we see reacts, so automatically it's going to be chemical. Explodes, well, in order for us to see that it's explosive, we need to see it take place, so that would be a chemical property. Hardness will not change our matter. Boiling point, when we boil water, it's still water regardless of whether it's boiling. So again, it doesn't change to something else. And 17 is a little tricky. Can neutralize a base. Well, the base is a complete opposite of an acid. And so let's say you have a substance that's acidic, and then you add a chemical to it, which makes it no longer be acidic. Well, it had to go through a change in order for you to observe that property. Same thing with the base. If you have a base, okay, kind of like ammonia, and it's dangerous for us, it'll irritate our skin. But if you want to take that ability for it to irritate our skin, we're adding or we're changing its chemical composition, so that would be a chemical property. Okay, the back of our homework. When we look at properties again, length, physical because we can observe it. Odor as well. Why? Because we can observe these properties without that substance changing to something else. Reacts, again, it has to change, so automatically that would be chemical. All right, the list above name 2 intensive physical properties. Again, remember, intensive has to do with those properties that it doesn't matter how much of that substance you have, that property is always going to be the same. So my favorite ones to write down are boiling point, because water is going to boil at 100 degrees Celsius. No matter what, even if you have 1,000 liters or if you have 1 milliliter, it's going to boil at 100 degrees Celsius. Okay, so it doesn't matter how much water you have, it's always going to boil at 100 degrees Celsius. Another one of my favorites is density, because the density of pure gold will always be 14.1 grams per milliliter, whether you have a kilogram of gold or 1 gram of gold. Okay. All right, extensive properties are those properties that depend on the amount of that substance that you have. So again, one of the more obvious ones, mass. Mass will definitely depend on how much of the substance you have. The more of that substance you have, the greater the mass, the less the mass. Another extensive property would be length. Okay. If you increase the length of a ruler, again, it's increasing. If you decrease it, then you're going to have a shorter ruler. All right, for each sample below, determine if the contents represent an element, a compound, a homogeneous or heterogeneous mixture. Okay, and then we have to circle if we can separate these substances by physical means, a box if we can separate them by chemical means, or a star if those are pure substances. Okay, and so again, in this case, if they're physical means, there's no chemical reaction. Chemical means it has to be a chemical reaction, and if they're pure substances, we're talking about elements. Okay. All right, so iced tea with table sugar. This is a mixture, and again, iced tea looks like it's just one. Okay, it's constant, the same throughout, and so in this case, it would be a homogeneous mixture. Can we separate these? Can we separate the sugar from the tea, from the water? Yes, we can. Okay. Again, there's no chemical bonds in between mixtures, and so these can be separated by physical means. So in this case, I'm going to go ahead and add a circle. aluminum metal, okay, that is an element, so it's pure. So in this case, oops, sorry, I put the wrong thing. I'm going to write element, E for element, but this is a star, okay, because again, I can't separate it. Table salt, that would be table sand and mixed in together. We should be able to tell the difference between those, so that would be hetero. And I can separate it by physical means when I put a circle around it. Copper metal, that is an element. It's pure, okay, I can't separate it anymore. Okay. Sulfur, another element. Water, that's a compound, okay, and so in this case we would have a C for compound. And in order to break these two molecules apart, I have to use a chemical reaction, okay, so I'm going to put a box around compound. Olive oil and water, that's a mixture. Well, they're not going to combine, so you can tell that there's two different substances in there, so that would be heterogeneous. And we can separate them by physical means because there's no chemical bond between the olive oil and the water. Kool-Aid and water, again, we have another mixture, but this one looks the same throughout, so it's going to be homogeneous, and we can separate it by physical means. Baking soda, okay, because all these elements are within the same formula, that means that we have a chemical bond that exists. So baking soda is a compound. In order for us to break apart these bonds, we need a chemical reaction. Iron is an element. Okay, it's a pure substance. Metal and sulfur dust, let's say they combine them. Because they're not in the same formula, we have and in between. Okay, as just a combination, so that would be a mixture. Now, iron has a like a metallic color, sulfur is yellow, so we would actually be able to see the difference, okay, between the two. We would be able to separate it if we were to combine them. A magnet, for example, will attract iron, and we would be able to separate the iron from the sulfur. Carbon dust, pure element, okay, we can't separate that anymore. Stainless steel, okay, stainless steel is composed of all these things. Okay, and so in this case, well, it would be a mixture. It would be, but it appears all the same, so it would be a homogeneous mixture. This one, even if it take a lot of work, we would be able to separate by physical means, because again, all these elements, 2, 4, 6 elements, they're not bonded to each other because they're separated by a comma. Copper sulfate, that means that this is a formula, so there is a bond that exists between those, so that would make it a compound. To separate it, I would need a chemical reaction. A speckled rock, you can tell it's a mixture of rocks, okay, that probably got compressed to each other, and so that would actually be a mixture, so it would be heterogeneous because you can see the different parts of it. You can break that rock into smaller pieces and separate the two different colors. Crude oil, and crude oil, you have a mixture, so here's 1, 2, 3, 4. 4 different substances make crude oil. So it's a mixture, but it's going to look the same throughout. It's going to look all dark and very thick, so it's going to be homogeneous, but we would be able to separate. That's actually what they do. They separate these 4 from each other, and that's how we get the gasoline, for example, that we use for vehicles.